we're going down to the lovely Mesilla Valley of southern New Mexico. Rich Pratt, tell us about corn.
I would love to tell you about corn, or at least a little bit. I want to express my appreciation to the organizers and to the hosts for putting together a terrific grain school. I've really enjoyed the talks so far. I've been learning a lot. Panelists have really been digging into some important issues that I may touch on some of them, and I've certainly learned a lot so far. So let's talk about where we are here. Dan mentioned the beautiful Mesilla Valley just south of us, and here we are in the Las Cruces area. And you've heard reference to the Four Corners state and to the Southwest. And, you know, before all these borders were all over the place here, you know, this was a fascinating area with a lot of shared culture and history. And so I want to add Sonora and Chihuahua and the Sierra Madres to this map. And I want to focus in a little bit. I'll just spend a moment with respect and with admiration and great thanks for the innovators, the selectors who selected maize through the centuries to give us the amazing present day maize that we can appreciate. I asked Nana about the audience and about what I should talk about. She said, talk about what you love most about maize. And so I do appreciate very much the beauty and the genetic diversity of maize. So we'll talk about that a little bit, and we'll also talk about some of the practical production and I love that new term, the grain chain. Talk a little bit about what we're doing, working with some of our producers and end users here in New Mexico. This is a comment I'd like to share from a farmer at one of our field days, that blue corn is the gem of New Mexico. And I think in many ways it is, and I think for many others, it's a gem for them as well. If we take a little closer look at the corn kernel, I was really glad I could finally find one figure that mentioned the alurone, this very thin layer here underneath the pericarp. That's where we find a lot of those pigments that give those beautiful colors. And to really get some of those intense blues that are almost black, there's a double alurone layer. And so here you see the majority of the kernel is endosperm that's filled with starch and protein. And here in the germ, we know there's a lot of oil associated with that region. And I'd like to take a little closer look at the kernels and some of these features, because the appearance, the physical texture, the size, the composition, all of these things are very important for many different reasons. So if we take a look at a corn kernel, here with a longitudinal section, we can see sort of this white starchy portion, and then this darker, what we call vitreous or flinty portion. So this hardness or vitreousness is interesting, and it has a lot of implications in the value chain, if you will, because different types of kernel texture are preferred by different end users who produce different products. So the hard or vitreous corn we call flint corn. The soft we call floury or flour corn. And then the dent corns are kind of a balance between those two. And that's really what kind of became, the US #2 dent commodity corn. because it's sort of a compromise for every end product in a way. So there's an array of kernel types, and you can have snacks from the popcorn if you blow up these small, very hard kernels. And then from the dense, we're making feed and fuel. And from the, whoops, my screen is kind of covering up the sweet corn. If you have a lack of an enzyme to produce starch, you stop at sugars and you have this sort of shrunken endosperm. And for a lot of folks, sweet corn is their favorite vegetable. And in more recent years, the floury corn, that type of kernel textures become important in forage corn because it aids in digestibility. So if we look at the compositional traits, I'll sort of talk mostly about the things over here on the right side, and sort of this is sort of the geek portion here. If you want to look more in detail about the different proteins, for example. So we know the kernel's mostly starch, and there's a couple of different starches, and if you shift those starches from the ratio from one to the other, you change the properties of that starch in the kernels. The proteins, the term zein or these zein proteins here are alcohol-soluble proteins, and there are different ones. Alpha-zein, we kind of go through the Greek alphabet here. And this gets a little bit important as it relates to nutrition because the zeins, the alpha-zeins are the majority, and they're low in essential amino acids, lysine and tryptophan. There's also been work at CIMMYT primarily. It turns out that if you have a mutation called opaque-2, it boosts the lysine level, but it converts the kernels to a softer, floury texture, which is not desired for some of the end uses. And they figured out that there are some modifiers that restore the hardness, and they call that quality protein maize, or QPM. Oils, some companies really sort of selected for very high levels of oil to see if that would enhance the feed quality and so on. It was marketed for a few years, but it turned out to be perhaps kind of a bust. So if we take a closer look at where are these starches and proteins, well, they're in what we call starch granules, these spherical bodies. And then these protein bodies, these much smaller bodies, are associated with the surface around the starch. And what we find then is this is the view of a floury endosperm kernel, and this is the view of a vitreous or a flinty kernel. And when light passes through the kernel, it has to bounce around a lot through these refractive indices because of the airspace between these granules, whereas it's more of a direct path through the vitreous endosperm. So what happens then is if you do candling, if you have a light source behind an object, this was done quite a bit with eggs in the day, you can see that a normal type, quote unquote, a dent type, has these proportions of soft and vitreous endosperm. So here the opaque-2 type with a higher content of amino acid lysine is opaque because it's a floury kernel. Then the Flint types have a lot of this vitreous endosperm, and then these QPM types, the modified ones, basically have that sort of more or less even ratio. So just to look at the protein body formation, what we find is these alpha-zeins that are low in the lysine are the ones that accumulate during maturation and fill up the protein bodies with these other types of zeins in the peripheral area. So when you reduce the content of the alpha zeins, you shift to a greater concentration of these other proteins that have a little higher level of the essential amino acids. So this kernel texture is important for various reasons, for optimizing different end uses. And that kernel texture is really the result of this three-dimensional coordination of starch and protein. So I just wanted to share a little bit of that sort of the background of that. So if we think along the line of the value chain from the field to the table, what's important to a producer, to an end user, to a consumer. And if we think about it, kernel hardness becomes sort of an integral part of what's important to multiple participants in the value chain. It's associated with dry down in the field, with insect resistance, with harvestability, storage and processing, and milling performance. So the southwestern land races are mostly flowery types. And so we asked the question, and a lot of our producers here in New Mexico are wondering what the potential is for producing some of these heirloom varieties as heritage grains. And so what are some of the potential opportunities and pitfalls? And just this morning, I received this reference about a study that's been done in Mexico entitled Opportunities in Blue Maize Markets for Smallholder Farmers. And I have the link here. If that's of interest, I'll leave it up for a while. And so you're probably aware that more and more people are appreciating blue corn. And there are more and more opportunities for production and marketing of blue corn. This is happening in Mexico and the United States. And someone shared with me, a bag of blue corn chips produced in Poland last year. So if we think about heirloom varieties, if we go back to the Corn Belt for a moment, Reed's Yellow Dent was a very important open pollinated or heirloom variety. Here in southern New Mexico, there is a variety called Mexican June corn. One producer was kind enough to share 14 ears with me. I'm aware of one producer in Arizona, and we have a publication in preparation now about Mexican June that we call a nearly extinct variety. And we have here a photo of New Mexican flowery type of blue corn. So what are some of the potential advantages and disadvantages of growing these open pollinated varieties? So, well, there's a mixture of genetic types in an open pollinated variety, and that provides some sort of genetic buffering, if you will, against the variable conditions in the field. The seed is less costly. The producer can save their own seed. It does need isolation. It doesn't require the controlled crossing of modern hybrids and so on. Yield, as we saw some data earlier, is generally a bit lower than for hybrids. Stock quality can be a problem, especially if growers try to plant it at too high a density. Harvesting might be a problem. Mechanical harvesting, our speaker referred to the challenges, say, of mechanical harvesting in traditional farming systems. And so these traditional varieties aren't necessarily so well suited to ease of mechanical harvesting. Um, One of our other speakers earlier talked about the importance, I think maybe that was Brooke, of the good local story. That's important, increasingly important to end users. Um, the market price may convey a premium. I believe one of our other speakers alluded to that. So if we talk about food grade corn production, there's really a need to focus sort of on the priority traits. Safety is probably number one. Freedom from mold contamination, mold producing toxins. Non-GMO varieties are certainly required for organic certification. And this raises the testing issues and the ability of people to maintain the purity of their varieties when they're not sure what their neighbor's doing, perhaps a quarter mile down the road. So the quality factors that are required by the end users, the hardness, the size, how many off-color kernels can there be, what is the nutrient content and quality. And so there's my understanding in sort of in the value chain is the need to focus on the cost per unit of production. In the market, there can be wildly different prices and premiums that may or may not be transmitted during one season. The scale is very important, and we've heard reference to that earlier. And we've heard reference to the importance of how much cost and price does transportation add. And I think we heard Montana's the number 4 state. I think we're number 5. So there's some pretty big distances involved sometimes. So here's masa and here's real tortillas. I hope you've had the opportunity to experience real blue corn tortillas. And if you haven't, why please, when things kind of get back to normal, please come down and see us in New Mexico. So I just want to end with an expression of thanks to all who have achieved and preserved the genetic diversity of crops in the greater Southwest. And I certainly hope that it will remain a hotspot for diversity. So with that, thank you all very much, and please stay safe and be well.
Dr. Pratt, thank you so much. I think we got about 1 minute or so for some questions. I see one
Great.
that came in here. I'm asking what makes popcorn pop well. So when you're selecting for seed stock, what kernel shape is best? Small, round, hard, starch. Jared is saying that his has many pointy pine cone types, and he loves the Dakota black popcorn.
Yeah.
Also, just another question, since we're going to combine it here, I was curious if you know of a good Southwestern landrace variety that has high lysine content, but also has that quality protein in order to make it kind of versatile or like
Sure.
a monogastrid type feeding for chickens and pigs.
Right. So for the first question, I don't have that much experience with popcorn, but I think you have to kind of start at the end and work your way back for popcorn. My understanding is there are 2 main types of popcorn that are desired: the butterfly type that sort of spreads its wing out, and then the mushroom type that's sort of more compact, the kind of jack-in-the-box type. So let's just assume we're going for the butterfly type, the snacking type. I'm not real sure about what morphology is most important. I know there's the sort of rice type and some different types there. And the little bit of experimenting I've done suggested to me that it's a little bit more variety specific than it is sort of type specific. And the other thing that I've learned that seems to be very important is really ensuring that you have a really high integrity kernel. In other words, making sure you don't harvest it when it's too moist and then put it in a hot dryer, because you get stress cracks. And those stress cracks kind of let a little bit of that steam that gets going inside kind of sneak out a little, and it kind of reduces the explosion a bit. So I think I think the answer is, it's more about finding the right variety than sort of the right type per se, and making sure that it's really good sound kernel quality. I think those are the kind of the secret to success, if you will. To answer the next question about the nutrient content, I mentioned the QPM because I think there's a lot of potential there. I remember being at a table once with the president of the American Snack Food Association. And I said, wouldn't it be a great idea to have more nutritious corn chips? And the answer was basically, nah, chips are an impulse buy. I was really deflated, But I think society, we're coming around to understanding more about the importance of good nutrition. And so there are a few little isolated areas of the world where they've really been working with QPM, perhaps more so for animal feed. As you mentioned, obviously it's very important for chickens and so on. I do have a colleague who is working on improving the nutritional content. We've done a little bit of work on the side, and what I would say, Dan, is just please keep sending those signals, that it's desired, it's wanted. We would like to see enhanced nutrient value in human food and in feed grains. And hopefully the breeders and the farmers, seedsmen and seed savers will respond. We've done limited measurements, mainly because it costs a lot of money to do all these nutritional analyses. We've seen some variation, but primarily within a band of about 10% variation. So probably not something that we probably have to go to these specific genotypes and bring them into breeding programs. We haven't yet seen much natural variation, but then we haven't looked a whole lot yet either, because it's expensive to go look.